have to share our video link, as well as we have to upload this video on YouTube. So like this is under the guidelines. This will be
Yes, but it will be uploaded by.
this will be uploaded, like there is no such deadline for that, but we try to upload it on that same day or in the next day. So this
Okay.
will video will be uploaded at least by tomorrow.
Okay, thank you.
Yeah, thank you.
Ma'am, yesterday's video will be available or not?
Yeah, what, Prinita?
Yesterday, yesterday's video.
Actually, I don't know who was the TA for the yesterday, so I don't know when he or she will upload this video. But under the guidelines, we have to upload this very soon. So I know my name is Jyoti Sharma, and I will be doing TA-ship for this course, Air Pollution and Control. And my live session will be from 6 to 8 every Monday. So let's proceed with this. So here, this is my brief introduction. I'm a PhD student right now in ISER Bhopal, and I had my MSc in Environment Management. Shivam, you want to say something?
No, ma'am. Continue.
Okay.
Oh,
So
sorry, ma'am.
because you raised your hand, that's why I thought that you want to say something. But anyway, so this is my brief introduction. I'm PhD student. I had my MSc in Environment Management from Forest Research Institute, Dehradun, and I had my BSc in Botany Honors from University of Delhi. And because I'm a PMRF research fellow, so this is mandatory for me to teach 50 hours annually. So that's why I opted for this NPTEL platform to teach. And I have some kind of I have some basic knowledge about this air pollution and control. So I will discuss with you the problems we have, the topics we will try to cover. We have lots of MCQs. So this is the way we will proceed. So I have lots of MCQs, and we will try to find out the solution of it. But with the discussion, you people are welcome to speak, to communicate. If you think that your communication skill is not that much good, I will encourage you to speak, even if you have some kind of low confidence. Sushil, you want to say something? I don't know why people are raising the hand and they are not speaking, but anyway. So if you think that you are somewhere in that position that you can't speak, you can't communication, so I will welcome you to write in the chat box if you have some kind of problem, if you are facing some problem in understanding the concept, understanding the MCQs or the solution. So your participation, actually whenever you will participate, this will give you the confidence, the first thing. The second thing is, this will make you alive in this session. So I think it is very clear from me. Whether you think that you want to speak in Hindi or English, you are welcome. Okay, but I will encourage you everyone to speak out. Okay, so I will start with some concept, even with some MCQs. And if you have something background knowledge about it, I will welcome again you to speak about it. Okay. So, should we start, everyone?
Yes, ma'am.
Yes,
Uh,
ma'am.
okay,
Yes,
thank
ma'am.
you. Because the topic of this, uh, okay. So, because the course name is itself Air Pollution and Control, so we must know what do you mean by air pollution and what do you mean by the control it, how we can manage it, how we can mitigate it. And these terminology are different, and this will give you something different meaning of it. Okay, so so firstly we have the definition of air pollution and air pollutant. This definition I borrowed from Air Pollution Act 1981 of India. Okay, so according to that definition, air pollutant we can define as any solid, liquid, or gaseous substance. Means air pollutant is not only gaseous. For example, you people are saying that carbon dioxide is increasing and this is a kind of pollution, or let's say the sulfur dioxide is increasing. Sulfur dioxide is only the gaseous form, but the air pollutant can be solid. For example, can you give can you give me one example of solid substance that can be act as the air pollutant? Yes, anyone? Write in the chat box. Any solid substance that we can call it air pollutant?
Hello, ma'am.
Yes, yes. Vinay?
Ma'am, heavy metals can be
Yes, heavy metals. For example, can you give me one example of heavy metal?
arsenic, cadmium,
Arsenic, cadmium,
lead.
and the simplest one is particulate matter,
Yes, I was
dust.
about to tell, madam. PM 2.5 and PM 10.
Yes, exactly. So particulate matter are solid and liquid in nature, no? So we can classify them into either solid or in liquid. Then gaseous substance. Can you give me some example of gaseous substance that can be act as a air pollutant?
Aerosols.
Aerosols are solid or liquid. Some very rarely it is gaseous in form.
Carbon monoxide,
Ma'am, ozone,
carbon
Yes,
fan,
yes.
CFC.
Methane.
Methane, CFC. Someone, Manish told me CFC. Yes, SOx, NOx. That is
Methyl
sulfur
isocyanate.
dioxide,
Methyl
nitrogen.
iso-
Yes.
Methyl
Anyone?
isocyanate. Methyl isocyanide.
Yes, methyl isocyanate. You are talking about Bhopal tragedy. I will discuss about it as well. Any more guesses?
carbon monoxide, ma'am.
Carbon monoxide. Yes. So we have a list of solid, liquid, and gaseous substances. But when we call it as a air pollutant, we can't call carbon dioxide as a air pollutant. Why? Can anyone tell me why we can't call this carbon dioxide as a air pollutant?
It breaks ozone molecule.
Actually, this carbon dioxide is like it is present naturally in the atmosphere. It is a permanent gas, and whenever it is not affecting us, okay, till it is not affecting us, it we will not call it as the air
Ma'am,
pollutant. Yes, Tina?
if we compare both carbon monoxide and carbon dioxide, I think carbon monoxide is highly dangerous than carbon dioxide because carbon dioxide is the byproduct in the reaction and
Yes.
it affects the environment but in a very less amount.
Yes, I will discuss about it because like carbon dioxide is a end product, and we can there is a, because this is a natural gas, right? This is a natural gas in our atmosphere. We can do some kind of mitigation about this carbon dioxide, but for this carbon monoxide, this is very dangerous, and we will talk about it. Sudesh Yadav, you want to say something?
Yes, ma'am.
Yes.
मैम जो कंसंट्रेशन है
Mm-hmm.
ऑक्सीजन की वो सिर्फ 20.9% समथिंग है एज कम्पेयर टू नाइट्रोजन नाइट्रोजन इज अबाउट 75%, राइट?
Yes,
सो
78.
मैम
Yes.
क्यों हम सिर्फ कार्बन डाइऑक्साइड को ही क्यों मेजर कंपोनेंट मानते हैं एयर पोल्यूशन का एज कम्पेयर टू नाइट्रोजन गैस?
सी इसमें डिफरेंस होता है बच्चे. कार्बन डाइऑक्साइड तुम्हारी इनर्ट गैस नहीं है. नाइट्रोजन जो तुम्हारा है 78%, वो तुम्हारी एक इनर्ट गैस होती है जिसका जो एक ग्रीन हाउस गैस भी नहीं है. ग्रीन हाउस गैस वो वाला होगा कि जो तुम्हारा टेम्परेचर को इंक्रीज कर देगा. उसकी वजह से वी विल टॉक अबाउट इट एट लेंथ कि वो तुम्हारा रेडिएशन को एब्जॉर्ब करेगा. जो लॉन्ग वेव रेडिएशन होगा उसको एब्जॉर्ब करेगा. उसके एब्जॉर्ब करने के बाद उस टेम्परेचर तुम्हारा इंक्रीज कर देगा. ये है रोल कार्बन डाइऑक्साइड का. ये कोई इनर्ट गैस नहीं है, पहला चीज. दूसरा चीज, ये ग्रीन हाउस गैस है. बट नाइट्रोजन की बात करें तो नाइट्रोजन बहुत ही इनर्ट गैस है. ये इंटरफेयर नहीं कर सकती तुम्हारे साथ या एटमॉस्फेयर में रिएक्शंस के साथ. इसीलिए हमारा नाइट्रोजन इनर्ट गैस माना जाता है और इसका इफेक्ट नहीं होता. बट CO2 is kind of dangerous gas because it may lead to the global warming. Is it clear, Sudesh?
Yes, ma'am.
Okay. So, carbon dioxide is not an air pollutant, but if the concentration of CO2 is larger as comparison to what it was present initially, then we will call it the air pollutant. Okay. And the second thing that we have to keep in our mind, that air pollutant will cause some harm or damage the environment. For example, if your CO2 concentration is, for example, 280 ppm, so this concentration will not affect the human health or the environment. But right now, can anyone tell me the concentration of CO2 in our atmosphere? How much ppm we have?
ppm not sure, but I think 0.03%.
0.003%. Yes, but if we are talking about ppm, so it is approximately 430 ppm. Okay, so means out of 1 million, our 430 molecules are of the carbon dioxide, and every year this ppm increases. Before industrial revolution, it was like 280 ppm, but right now it is increasing constantly. So because it is increasing, it is leading to the global warming. It may also lead to some another reaction. That's why this is the air pollutant. So there is 2 or 3 characteristics feature. Based on that, we can say that this is air pollutant. The first thing is that it should be in environment. Okay. The second thing, it should damage or harm something, like for example, human health, or let's say the environment, let's say the building. So it should harm something that may cost us. Okay, so that's why the air pollutant can be any solid, gas, or liquid, as you people gave me some example of it, and that may cause harm or damage the environment, humans, plant, or animal, or even damage the property. In 1987 amendment, the noise was also listed into these harmful substances. And if we talk about the air pollution, then if there is the presence of any dangerous pollutant that will make the air unbreathable, then we will call it the air pollution. So I think air pollution and air pollutant is clear, because whole topic is about this air pollutant and air pollution and how we can mitigate it. So can we proceed further? Okay, so we have 2 different of pollutant. Okay, the first is primary pollutant and the second is secondary pollutant. Primary pollutant is when something is happening, okay, then this reaction will release directly the this pollutant in the atmosphere. Okay, so it will directly come out from the source. For example, you are like you are going somewhere with your vehicle, then this will release carbon dioxide, let's say nitrogen oxide. So this will be the primary pollutant. But when this primary pollutant will go into the atmosphere, will react itself or with some other chemicals, then we will call it the secondary pollutant. For example, nitrogen dioxide. Keep in mind that whenever a vehicle emits NO, that is nitrogen oxide, but this nitrogen oxide will react with the oxygen and will produce the nitrogen dioxide. So nitrogen dioxide is the product when this NO, that is nitrogen oxide, has been released into the atmosphere and it is reacting with the existing gases in the atmosphere. So this will be the secondary pollutant. So can we see here some example of this? Can you give me some example of primary pollutant? Can anyone write in the chat box or communicate with me? Can you give me some examples?
Volcanic eruptions. Volcanic eruptions.
Yes, sulfur dioxide. How sulfur dioxide? Whenever
Because when
there is
we
a
burn any fossil fuel, then it is giving the sulfur dioxide.
yes, because fossil fuel have the sulfur, and when we will react it with the oxygen, then it will give us directly to the sulfur dioxide in the atmosphere. So this, yes, carbon
Volcanic
dioxide,
eruptions.
yes.
Volcanic
Like,
eruptions.
what?
Volcanic eruptions.
Volcanic eruption, what type of gas it will release will be primary pollutant. So can you give me some name of that gas?
H2SO4.
No, H2SO4 is not a primary, it is a secondary pollutant. Because this sulfur dioxide will be the primary pollutant. Okay, this primary pollutant will go into the atmosphere, will react with the water, then water plus SO2, that is sulfur dioxide, will give you H2SO4, that is sulfuric acid. So after emitting as a SO2, it will react with H2O. So this sulfuric acid is the secondary pollutant. Can you tell me, like, ozone, O3, either it is a primary pollutant or secondary pollutant?
Secondary pollutant.
It's a secondary pollutant.
Primary pollutant.
It is a secondary pollutant because the photochemical reaction takes place here.
Yes, photochemical means if there is
Sunlight
In the
falls
presence of
into it, and
sunlight.
the atom splits into two molecules.
yes, exactly. So if you have oxygen in the atmosphere and you have nascent oxygen, that is only one molecule of oxygen, this will combine in the atmosphere and will give you ozone. But in the presence of sunlight, in the presence of VOC, we will talk about this volatile organic pollutants as well. Okay, so it is, I think, clear to you what do you mean by primary pollutant and what do you mean by secondary. Primary means this is directly from a source directly into the atmosphere. But whenever it is the result of chemical or physical interaction between the primary pollutant themselves or between the primary pollutant and other atmospheric component, then it will give you the secondary pollutant. Okay, so I think it is clear to you what do you mean by pollutant, because I have one MCQ related to the pollutant. Here you can see this is the schematic graph that is showing you primary pollutant. For example, from the natural sources, for example, volcanic eruption, from vehicular emission, from factory, it is giving you CO, CO2, particulate matter, SO2, NO, NO2. This NO2 is very ambiguous actually. This is also the part of the secondary one. Then most suspended particle, and whenever they are reacting with other component in the atmosphere, it will give you the secondary pollutant. Okay, so here is the question. Can you tell me the answer of it in the chat box? Can anyone give me the answer of it? The question is, like, there are two terminologies. The first is contamination, second is pollutant. Okay, so there is some difference between contamination and pollutants. So
C.
D.
yes, the
Option
answer,
C.
yes, most of all you gave me the
Pollutants
answer.
are harmful substance, but contaminants are not.
Please pardon me, can you ask once again?
Pollutants are harmful substance, but contaminants are foreign particles only.
Yes, means like pollutants are you can yes, Swatshiri, you want to say something?
I want to say that the option will be D, and I just want to write in the chat box, but raise the hand. So.
Okay,
Bye.
okay. The answer is D. Why you people are selecting C? If you people have some doubt, you can ask me. See, there is a two terminologies. The one is contamination and second is pollutant. Okay, contamination is that if you are adding something in somewhere that is giving you some another thing. For example, in the laboratory, there is a laboratory where there is a no fungal infection or fungal contamination, but because okay, I will give you the yes, Pritish, you want to say something?
No.
Okay, Hanan gave the right answer. All pollutants are contaminants, but not all contaminants are pollutants. Yes, contaminants are that is that is adding something into your atmosphere that is not favorable to you, but it may be that it may not harm you. Okay, but whenever this contaminate start harming you, then we will call it the pollutant. Okay, Pratyusha and Ritika, yes, you want to say something? Uh, we need to select the incorrect statement, not the correct. So if you people have some doubt in C, then pollutant is the substance that alter the composition of the natural atmosphere. This is the right statement. Why? Let's say, for example, we have carbon dioxide. Initially, it was 280 ppm, but right now it has been increased to, let's say, 430 ppm. So it is altering the composition. So this is the correct statement. And the option was we need to select the incorrect statement. So that's why C is not the answer, but D is. Everyone is clear about this pollutant and the contaminant. Okay. We also have somewhere we can see pollutant is a harmful or poisonous substance that pollutes something. But contaminates is the foreign substance, or let's say the existing substance or the impurity that contaminates something. It may or may not be happen that it will harm, but it will if it will harm, then this contaminant will known as the pollutant. Okay, then the pollutant always create harmful effect, and the contaminant may not always create harmful effect. As someone told me that all contaminants are not the pollutant, right? Then contaminant can be either foreign substance, or this is not relevant for you. Okay, you people should know something about atmosphere, because if we are talking about the air pollution and control, then you people should at least know something about atmosphere, how much gases we have, how much concentration of that gases we have. Because whenever there is an alteration in the composition of the gases, then we will call it there is something that is happening in the atmosphere, something that is disturbing, and we will call it as the air pollution, right? So we should know the exact concentration, initial concentration we have. Based on that, if we will have some baseline, we will say that yes, initially we had the 20.98% CO2, but now it is decreasing. Then we will say like something is happening, air pollution is being happening. Okay, so we must have some baseline. We must have some permanent concentration of the atmospheric gas composition. So right now we have nitrogen, oxygen, that is making a lot of chunk of this gas atmosphere. Then argon, xenon, neon, hydrogen, helium, a lot of gases we have, and the percent by volume is given here. Okay, and can you because this atmosphere have some layers, one above the one. Okay, so initial at the very near to the surface we have troposphere. Above it we have stratosphere. Above that we have mesosphere, then thermosphere, and then exosphere. Okay, so can anybody tell me on what basis such layer has been divided? One is like based on the height from the earth. Yes, height from the earth, this layer has been formed. But on what basis we can divide or classify these layers?
Temperature.
And temperature.
Another one, pressure. Can you
Pressure.
yes, based on pressure as well. As you will go above far from this earth surface, then there will be very less pressure. That's why you will find very like thin layer of the atmosphere there, and near to the surface there is a very dense air concentration. So based on temperature, based on pressure, we can classify it. Okay, and this layer has been divided. And one thing is also very important is that these layers are rarely mixed with each other. Why they are not mixing with each other, we will see in the next slide. Okay, so first we have troposphere, where most of the activity happens. For example, cloud, rainfall, all the pollution, uh, everything happen in the troposphere. Very rarely things is there in stratosphere or mesosphere or thermosphere. Okay, so this is from 0 to 12 kilometer. After that, we will have the stratosphere. Why stratosphere is relevant? Can you tell me one point? Because there is something that protect us from the ultraviolet
An ozone
radiation.
layer.
Yes. So in the stratosphere, we have the ozone layer that can protect us from the ultraviolet radiation. Above that, we have the mesosphere. Mesosphere protect us from the meteors. Like every meteors can be burnt out in the mesosphere. Then we have the thermosphere and the exosphere. You can see the height of it. And there is one radio sonde. What do you mean by radio sonde? Do you know about it? Anyone? In the stratosphere. Have you seen that balloon? There is a one balloon, and attached to it has some kind of sensors. Okay, when we will let that balloon to go in the atmosphere, then it will give you the vertical profiling of the atmosphere. Like it has some sensor that will give you the information about the temperature, about the relative humidity, and there are so many variables. The information of this we can get from this instrument, and this instrument go up to the stratosphere. So at each height we can get some information with this instrument. Okay, and if we are talking about this vertical profiling of the temperature, then we will see how this will work. What happened? Can you see the presentation? Something happened.
No, not yet.
Decrease and increase of temperature on a different layer of atmosphere.
Can you see my presentation now?
Yeah.
Yes, yes. And now it's visible now.
Yes,
Oh,
yes.
okay. Now you can see that in troposphere, the temperature is decreasing with the height. Why this is happening in the troposphere? Can anybody tell me? Why in the troposphere this temperature is decreasing with the height? As we are going upward, then our temperature, see, from here 20 degree to minus 52 degree. Why? This is because of that pressure. Okay, if you know this lapse rate, have you heard about this terminology, lapse rate?
Yes, ma'am.
Yes, ma'am.
What do you mean by lapse
Changing,
rate?
changing in temperature with respect to the height and altitude.
Yes, and because in the upper atmosphere there is a very less pressure, because of that pressure your air will expand, and if will expand then it will be cool down. So whenever there will be the like this temperature will decrease with the height in the troposphere. But you can see that in the stratosphere this temperature is increasing. Why this is happening? In stratosphere temperature temperature is increasing with the height. Why?
I think due to the ozone layer. Ozone layer is means it absorbs the solar radiations. So I think temperature is increased.
What's the name of that radiation that is absorbing? Ozone is absorbing that radiation.
UV,
Ultra-
UV radiation.
Short
Ultraviolet.
wavelength UV radiation.
Yes, because of that ultraviolet radiation in the stratosphere, this temperature is increasing. Okay. Yes, Prem Sai, you want to say something? Okay, Kunal also gave me the right answer. Because of that ultraviolet radiation, this temperature is increasing. But in the mesosphere, once again, we have the decrement in the temperature with the height. Okay, so here in that mesosphere, we don't have the ultraviolet radiation. It will just act like the troposphere. So here, the lapse rate will play a very important role. Yes, Hemant. Okay, so in mesosphere as well, just like the troposphere, our temperature will decrease with the height. But in the thermosphere, again, it is just acting like the stratosphere. Why? Can anybody make some guesses? Why in thermosphere it is again increasing with the height? Because of ions. There are like in that atmosphere, at that level we have sun radiation, that is like there is a very high temperature, and atoms, there is no such gases, there are ions or the matter ions and atoms only. Okay, yes, ionization of ions. So based on that, this will increase again. Okay, so I think in let me tell you that in UGC exam, such type of question has been asked. In which layer the minimum temperature goes? Okay, so this is the mesosphere, because you can say that in mesosphere approximately -92 degrees Celsius, at the top of this mesosphere we have the temperature. Okay, the second question is, can you see that whenever there is a end of that layer, there is a straight line? So what do you mean by that straight line? In the let's say in the tropopause, in the stratopause, in the mesopause, why there is a straight line there?
There is no change in
Meeting of
temperature.
different layer.
No
No,
change in temperature.
this is
Adiabatic.
this is kind of, yes, of course, the constant temperature, and this is the stable layer. Because of that stable layer, you can't mix one layer to another layer. Okay, so this is the kind of stable layer that will separate one layer to the another layer. So you people must know in each layer from what temperature to what temperature we are going. The first thing. The second thing is like how much distance is from troposphere to stratosphere to mesosphere. So you must keep in your mind the distance. Like from troposphere, it is 0 to 12 to 18. Then from there to stratosphere, it is up to 50 kilometer, then up to 80 kilometer, and then beyond it. So such kind of things you must know if you are preparing for some environmental sciences net exam or something like that. This is important for you. So this is the atmosphere, and most of the gases, whatever you are talking about, the carbon dioxide, the nitrogen dioxide, the sulfur dioxide, all gases are in troposphere. Ozone is in the stratosphere, but all these are very thin atmospheric layer. And here we can, in the thermosphere we will get only atoms and ions. In the mesosphere we will get some kind of oxygen and such kind of gases. But in the stratosphere we have a lot of gases, and this makes approximately 99% of atmosphere, like the mass of atmosphere, the 99% mass is within this troposphere. So this is very important, and this is very near to the surface. So that's why whatever is happening in the troposphere, we must know about it, right? So that's why understanding this temperature vertical profile and the atmospheric vertical profile is important to us. If we see here the gases that we have, troposphere, it is from 0 to 11. Temperature is 15 to -56. And here major chemical species are oxygen, nitrogen, CO2, and H2O. Okay. Then stratosphere, height is from 15 to 50. Here the range is -56 to -2. And here major chemical species is ozone. Then mesosphere, the height is from 50 to 83. Temperature range is -2 to -92. And here the major species are oxygen and the radical form of the NO. Then the thermosphere, here the height is from 85 to beyond, and temperature is -92 to 1200, and here the major species are very reactive oxygen molecule, and the reactive nitrogen oxide. Okay, so the next question we have for you is, in 1981, which air pollution legislation was adopted in India?
Ma'am, B.
B. Okay, can anyone
Air
tell
pollution.
me? B. Yes.
B. The
B
Air
for
Prevention and
give me
Control
answer.
of
B.
Pollution Act
Option D.
1900.
D. Yes. Everyone is with B only, not with A. Okay, someone told me D. Central
Ma'am, A
Motorway.
is in 1982.
Yes. Okay, you people know about it. Good. Yes, the answer is B only. Okay, this is Air Prevention and Control of Pollution Act 1981. Can you tell me when Environment Pollution Act came? In
1982.
1986.
1986. Okay. Okay. So we must know why there was the legislation, and why legislation make the law, that is Air Pollution and Prevention Act. So there was some reason behind it, why India acted on it. Okay, so the reason were, there were so many air pollution events worldwide. Okay, and because of that air pollution event, many of people were dying, many of people were having the disease based on that air pollution. And because it has become the worldwide concern, like what is happening in the atmosphere, what's the air pollution, and everyone should know about it. So there were some triggering point that led to the legislation of Air Pollution Act, right? So there are some events that we must know. The first is Great Smog of London in 1952. So this was the time in the London. It was the winter time, on December 5 to 9. Like, it for 4 days there were no radiation entering into that city, London. Everywhere the smoke, everywhere there is a no radiation. Because of that, the crop devastation, people were very facing very difficulty in the breathing. So there were so many problems. And why this happened? Because of the coal burning, because of that coal burning. And secondly, the meteorological conditions. Do you people know about the inversion? Anyone know about this inversion? A very specific terminology we have in the air pollution.
The increase in temperature with altitude.
Yes, exactly. You know that in the troposphere there is a decrement in the temperature with the altitude. Okay, but some condition, there is a some meteorological condition, because of some topography, it may happen that temperature is increasing with the height. And if it is happening, then there will be no mixing of gas. For example, if such condition is happening in the atmosphere, let's say in 1 kilometer there is a temperature increase with the elevation, then what will happen? This air pollutant, whatever we are releasing, for example sulfur dioxide, dioxide, it will not disperse. It will be here only in that area. So this is the bad effect of the inversion. And that thing only happened in the Great Smoke. There was a kind of inversion condition, means there was a no movement, there was no wind movement that can carry that pollutant to somewhere. Okay, so there was no wind movement. Secondly, there was a inversion kind of condition. Third, burning of coal was releasing so much smoke in the atmosphere, so it makes smoke for whole 4 days. And because of that, thousands of people died. So this was a very grave case of that air pollution event, happened in 1952. Okay, then this is kind of reducing pollution. Why this reducing pollution? Because this sulfur dioxide was releasing, and Like there was no any role of the oxidant, for example ozone or the sunlight. But if we see in the Donora smoke in 1948, here temperature inversion was there because of the zinc smelting plant and steel mills. There were again there was like different gases were released in the atmosphere, and because of that meteorology conditions, the smoke also smoke was happened there for some days, and because of that 20 people died and hundred of people got the illness. And even before 1952 or 1948, in 1930 there was one valley in the Belgium where the sulfur dioxide was trapped in the at some atmospheric condition, and because of that uh, some people were died. So like, can you see that we people were struggling for the freedom, and here because of you people can wait some minute, I need to charge my laptop. Sorry. Yes. So the first event was like a Belgium event, then Donora smoke, Great London smoke, then Cabville lead poisoning, New York City smoke, Mexico City air pollution, even if you know that Asian brown cloud, then Delhi air pollution. You people know about this Delhi air pollution, why this is happening. Can you tell me the reason why this is happening, Delhi air pollution?
Stack burn.
Vehicles.
Actually there are some comments like some people say that stubble burning is happening since 50 years, but why right now we are facing with this kind of pollution only?
Ma'am, deforestation.
Deforestation, okay, but
Ma'am,
why only
earlier
in the winter time? Why only in the winter time, and why only in Delhi area? If deforestation is happening, the effect must be over the India, not why only on India?
Because Delhi area is now a concrete jungle, so there is no air pocket, and especially at the night time, the air movement is very less in Delhi.
Yes, exactly. Narendra Kumar gave me the right answer. Because of, see, because of that vehicular emission will release carbon monoxide, nitrogen dioxide, sulfur dioxide. Okay, we have such kind of gases. We have the gas chamber. Okay, but if we have the wind movement, then this wind movement can disperse these gases. But Delhi has some condition in the winter, as I told you, the inversion condition, the first thing. The second is wind movement, because in the winter time Delhi has such kind of meteorology in such a way that there is a no wind movement, there is a no like air is moving, air is stagnant. Because of that stagnant air, such kind of smoke will persist over that area, and that will lead you to the Delhi air pollution. So no doubt particulate matter are coming from the stubble burning. Okay, then vehicular emission will give you the carbon monoxide and different type of gases. But because of the stagnant air, because of the meteorology, because it is the winter time, because of the air, because it is the inversion condition there over the Delhi, this will give you the air pollution every time in the winter time only. Okay, so there are so many air pollution events. Okay, and because of that air pollution event, the countries like Britain and USA were worried, like there should be something for that, and USA started making the legislation, making the laws related to the air pollution or the environmental pollution. Okay, so from there only some people gathered together, and they thought that yes, there should be a law in every country regarding this air pollution. And the one triggering point was the if you people know the Stockholm Conference. Stockholm Conference that happened in 1972, in which they discussed most of the country were sitting together in that conference, and they discussed that every country should enact the law. Okay, so this was the time. Yes, the world first conference to protect the environment that was organized in Stockholm, Sweden in 1972, and this was the point where people got to know about the air pollution everywhere. And this from there only we also got some idea to enact the law. That's why our first act, that was the Water Pollution and Prevention Act, came in 1974, just two years after this Stockholm Conference. Then after this Water Pollution Act, we came to this Air Pollution Act and then Environmental Pollution Act. So the triggering point were this Stockholm Conference and the air pollution events that were happening in the European country and in the American countries, right? Okay, so this I already have discussed. You people must know when this kind of act came into force. So firstly, we had the Water Prevention and Control of Pollution Act 1974, then the Water Cess Act 1974, then the Air Act 1981, then Environment Act 1986. So you people must know about at least about these 4 laws. Okay. This is very interesting thing. There is some kind of relationship between carbon monoxide, nitrogen oxide, and nitrogen dioxide. Okay, so and this relation is with the vehicular emission. Can any people guess from this what is happening in this curve? How ozone is moving, having the peak, and how this NO2 have different peak, or NO have different peak with different time, which is very relative to the vehicular emission. Can you people guess something from this curve?
Actually, ma'am, it is a atmospheric titration reaction in which the cycle goes on continuously.
Titration reaction, can you please explain further?
There is a reaction in which the cycle goes on between NO2 and this ozone O3.
Yes.
And this cycle goes on continuously. So this
so
is called as atmosphere.
Yes. So I want to know what gas trigger what? Yes, Yukta.
Ma'am, I feel that NO is a precursor to O3. O3 is rising, it is inversely related. Means as NO is decreasing, ozone is increasing. That means that the photochemical reaction is taking place and it is triggering for the formation of O3. So we can say NO is the main precursor for the formation of O3 because O3 is the secondary pollutant. So it is not directly emitted from any source. It is formed in the atmosphere due to the photochemical reaction. So this figure that actually this graph, it shows the diurnal variations of O3, NO2 and NO. So that clearly indicates that NO is a strong precursor of O3.
Yes, 80% explanation is correct. So let me correct once again. So this is happening with the vehicular emission. So if you know that every people go to office near to 9 to 12. Okay, morning 9 to noon 12. Okay, this is the time when there is a lot of cars, motorcycle, and four-wheeler on the road. Okay, because there is a vehicle on the road, this will give you the nitrogen oxide, that is NO. Okay, so in the atmosphere during the vehicular peak, you will get NO at the peak level. Okay, but because at the 10 or 11 a.m. sunlight will come into the atmosphere, and this sunlight will not sunlight right now, this NO is very reactive in nature. Okay, this NO will react with the oxygen in the atmosphere and will give you the NO2. Okay, as soon as NO is formed, this will react with the O2 oxygen in the atmosphere. This will give you the nitrogen dioxide. Okay, whenever there is a nitrogen dioxide in the atmosphere and sunlight is here, then this nitrogen dioxide and the sunlight will give you the, like, there will be the photolysis. Photolysis means NO2 will break down in the presence of sunlight into NO plus O. Okay, and this O will react with the oxygen, will give you the ozone. Okay, so whenever there will be the sunlight, this sunlight in the presence of nitrogen dioxide will create the ozone near the surface. Okay, and whenever there is a ozone, okay, this ozone can react with the nitrogen oxide and that will destroy the ozone. So the first thing is there will be NO. After that NO, this NO will react with the oxygen, that will give you the nitrogen dioxide. This nitrogen dioxide in the presence of sunlight will give you the ozone formation. So this is the kind of the sequence you will get. And whenever there is a ozone in your atmosphere near the surface, this is the bad gas, I'm telling you. This will give you the smoke like condition in the atmosphere. This will your eyes will irritate because of that ozone. This is very bad. If you people know about the good ozone and bad ozone, so bad ozone is present near the surface, but good ozone is in the stratosphere. So here the formation of ozone will be due to the vehicular emission, and the sequence will be like this: NO, NO2, and the O3. So here you can see that in green light, because of there is a peak at the 9 AM, then because of that, this will react with the oxygen and will give the peak of the nitrogen dioxide near to the 1 PM. And because of nitrogen dioxide, this will react with the ozone, and that's why this will give you the ozone formation at the peak near to 4 or 5 PM. Okay, so this is the traffic peak and the gaseous curve. This is not relevant right now for you. I should proceed it. Okay, the next question. This is very important topic. Which gas was released during the Bhopal gas tragedy?
Methyl isocyanate.
Methyl
Option D.
isocyanate. Option D. Everyone? Yes, Yukta.
Yes, D. Option D, madam. Methyl
Okay.
isocyanate.
Everyone is with option D? Yes. The right answer is option D. If you people have read something about Bhopal gas tragedy, can anyone explain about this? What happened? Why happened? Such kind of things. Can anyone explain?
We also seen that series on the Netflix about that Bhopal gas tragedy.
Okay, yes.
Yeah, 2nd and 3rd December night in 1984, that methyl isocyanate released from one of the plant which is manufacturing a pesticide
Yes.
for the green revolution in India.
Can you tell me the pesticide that was created, that was formed with this MIC?
7-carbaryl, madam.
Carbide, yes. Next, yes.
7-carbaryl, madam.
Yes, exactly. Okay, so let's see. We will talk about it at length about Bhopal gas tragedy. It was happened at the night of 2nd December. Yes, Yukta, you want to say something?
No, madam.
Okay. So here the gas involved was MIC, as you people already gave me the answer D, that is methyl isocyanate. And where it was happened, that was the company that was manufacturing some pesticide. Okay, and the name of that company was Union Carbide Indian Limited. Then what happened? Because you are the science student, you must know some reaction that happened at that time. Okay, so if it is the MIC, then how this MIC can be formed? Okay, you people have some idea about it. So MIC can be formed whenever it will react with the phosgene gas. Phosgene means COCl2. Okay, and how this COCl2 can be formed? When there is a carbon dioxide, carbon oxide plus chlorine, then it will give you the phosgene gas, that is COCl2. If we have one compound COCl2 phosgene plus methylamine, methylamine means CH3, that is the methyl group, NH2 amine group. If we have the reaction of phosgene with the methylamine, this will give you the MIC, that is methyl isocyanate and the hydrogen chloride. Okay, and this methyl isocyanate is formed in two stages. In first stage, if you see that we have the a hydrogen atom attached to the nitrogen, then this hydrogen atom is removed, and this will give you the MIC. Okay, so the clear thing is that firstly we will form that phosgene. Phosgene can be formed with the carbon monoxide plus chlorine. If we have the phosgene gas, then we will react it with the methylamine, then it will give you the MIC. Okay, and this MIC will be used to create the or to manufacture the pesticide. Okay, so if we have one naphthol and MIC and some catalyst, it will give you the compound carbyle, and this is the carbyle, that is the pesticide that we use. Okay, so the company was created to manufacture this carbyle, and this MIC was stored in some tank. Okay, and leakage of this MIC led to the Bhopal gas tragedy. Yes. Okay. Then because this MIC reacted with the water, it will create carbon dioxide. If there is the excess of water, then it will create 1,3-dimethylurea, and if there is the excess of MIC only, then it will give you the 1,3-trimethyl biurate. And these are very explosive gas. Like with the temperature, these gases will spread over the kilometer. Okay, so these were the products that were formed when this MIC were leaked and were react with the water. Okay. What? Not? Okay. Then there were some Yes, Yukta. Yukta, you want to say something? Okay.
No, madam, I'm in mute.
Okay, you raised your hand. That's why I asked.
Oh, sorry. No, madam. Please continue.
Okay. So there were some unsafe conditions that led to this Bhopal gas tragedy. First thing, whenever there is a temperature high, then MIC will act like the explosive gas. Okay, so there must be the refrigeration system. So there was like refrigeration system to cool that gas was closed for since long. So this was one problem. Second is, whenever there is a release of gas, this gas must be scrubbed, means must be absorbed by something, by some chemical, and such kind of system was also under designed or not prepared or not connected. Even there were some like temperature was not maintained, like there was no warning system there. If the what will be the wind direction, where this gas will go, in what direction, such kind of warning system were not there. There were like wall leakage system, to check this wall leakage system, it was like not available in that place. So like there were so many faults there that we found after this Bhopal gas tragedy, and because of that also we also enacted some law based on like what kind of safety we must have whenever we are building a company. Okay. There are so many unsafe conditions there. Okay, you people talked about this photochemical smoke. So the question next is, photochemical smoke comes under which scale of air pollution? A, B, C, D. Can anybody tell me? Meso, yes, meso. Anyone with A, micro? Okay, everyone is with B, and yes, B is right. Because let me show you. In micro scale is like within a building. Okay, indoor kind of air pollutant will come under this micro. If we are talking about meso, then if there is a effect of that pollutant or the air pollution within a city, okay, or within few kilometers, then this will be the mesoscale. Macro means whenever the effect of this pollution will be worldwide. For example, can you give me one example of micro scale air pollution problem, or mesoscale or macro? For example, I give you one example of macro scale. This ozone depletion, this greenhouse gas emission. This is the part of macro scale, because this will not impacting you locally, but with the globally. So this is the macro scale air pollution problem.
Ma'am, can we relate the sources of air pollution with these scales, like line sources or mobile sources?
Yes, exactly. For the micro scale, you can see that if you people know that particulate matter can't move longer. Okay, the effect of this particulate matter will be confined to few kilometer or meter. So it will come under the micro scale. But if you are talking about, let's say, urban heat island, this will be the mesoscale. Or let's say if you are talking about that photochemical smoke, this photochemical smoke is very pronounced in Delhi. So this is the mesoscale. So exactly your answer, this photochemical smoke will come under the mesoscale. Okay, so because this question was related to the photochemical smoke, so I must let you understand about this photochemical smoke as well. So here we can see that we have water. Okay, we have sunlight. If we have water, we have sunlight, then this firstly we have the nitric oxide. This nitric oxide will be released by the vehicle. Then we will like this will react with the oxygen, and this will give us the NO2. Okay, then this NO2 can react with the water and can give you the nitric acid. This is the one of the component of the acid rain. Okay, then if we have the nitrogen dioxide, this nitrogen dioxide in the presence of sunlight can create the photochemical smoke. Photochemical smoke have 3 or 4 components that is permanent. The first is ozone, O3, you can see here. The second is PAN. Can you tell me the full form of PAN?
Peroxyacetyl nitrate.
Yes, exactly. So we have PAN, we have aldehyde, and we have the ozone. These are the product of photochemical smoke. And this will there will be photochemical smoke when there is a sunlight, when we have the NO2, and the third important factor, VOC, that is volatile organic compounds. When we have these 3 things, sunlight, NO2, and then VOCs, this will give you the products such as ozone, PAN, and aldehyde. And these are very irritating in nature. These will create the brown haze around in the atmosphere, and this will lead to the photochemical smoke. Okay, so um, okay, next question. Which gas is colorful and highly irritating gas, which is formed by the photochemical reaction just above the Earth's surface?
Sulfur
As
oxide.
not sulfur dioxide.
Ma'am, ground level ozone.
Ma'am, it can be CO, carbon monoxide.
See, you can see the question. That is formed by the photochemical reaction. It is not the reactant, but is the product.
Ground level ozone.
Yes, this is ground
Yes,
level.
ground level.
As we saw in that picture, na. After that photochemical smoke, what were the product? Nitric acid were the product, PN was the product, aldehyde was the product, and the ozone was the product. Okay, and this ozone is, as I told you, this is irritating gas, and this is also the colorless gas, and that formed by this photochemical reaction just above the Earth's surface. So your answer will be ground level ozone. Okay, as you people already know about this good ozone and bad ozone, so whenever we are talking about this photochemical smoke, so this is the gas that is present in the troposphere, and we call it as the bad ozone. This is not that much right now important for you. Okay, the next question is, which of the following gas is termed as the silent killer? Options we have: methane, carbon dioxide, carbon monoxide, sulfur dioxide.
Carbon
Carbon
monoxide.
Carbon
Carbon
monoxide.
dioxide.
Okay. Why carbon dioxide?
Because it's not a pollutant and it is getting absorbed in the atmosphere, in the ocean and in the plant, but it increases the temperature, so it's a greenhouse gases, so a silent killer. Rather, carbon monoxide is a very poisonous gas. It will kill us in the minute.
But the answer is carbon monoxide.
Carbon monoxide causes cancer.
Carcinogenic.
See, why this is silent killer? We have 2 or 3 characteristics. The
It
first is,
combined with the hemoglobin.
yes, exactly, because it reacts
Because
with the
book chane mein
hemoglobin.
hai
I will discuss about it. The silent killer is, you will not get
Yes.
any information how you are feeling.
तो
Like,
चाहिए
it is colorless.
मैं
Someone is speaking. I should. Okay, so why silent killer? Because there is no smell, there is no taste. Okay, and there is no color. You can't identify it is the carbon monoxide. The first thing. The second thing is that because you people, because we all people should have oxygen that will bind with the hemoglobin. Okay, and because we need oxygen. Okay, and this oxygen should bind with the hemoglobin so that our blood can be purified everywhere. Whatever work we are doing, the carbon dioxide can be released from our body. But whenever there is the carbon monoxide, the affinity of binding of this carbon monoxide to the hemoglobin is that much strong that this oxygen will not bind with the hemoglobin. And when you are not taking oxygen in your body, but you are taking this carbon monoxide, then what will happen? You will be breathless. Like this will be the silent killer. You will not know what's the reason, what is happening, but it will make you die. So that's why I show you one thing. Yes. So carbon monoxide is odorless, tasteless, and very poisonous gas. Then compared to oxygen, its binding affinity is approximately 240 times greater with the hemoglobin. Okay, and this is the scientist Ashwir Helik who told about the affinity of carbon monoxide with the hemoglobin. So here we can see that we have red blood cell. On that red blood cell, we have some molecules of the hemoglobin. With that hemoglobin, molecules should be either oxygen or CO2, oxygen to take in, carbon dioxide to take out. Okay, but whenever there is a carbon monoxide, then this oxygen will not react with the hemoglobin, will not attach with this hemoglobin, but will be the carbon monoxide. And if you will not have oxygen in your body, how will you survive? That's why it's the silent killer. Okay, is it clear why it is not carbon dioxide but the
Ma'am,
carbon monoxide?
Yes,
ma'am, I have doubt in previous question that why we have choose ground level ozone. It can be a carbon monoxide. Now. It was also colorless.
See, okay, let me show you the question. This was irritating
Yes.
gas. Irritating was also the one word that you should keep in your mind. Your eyes will irritate. You will have the watery eye because of that gas. But carbon
Ma'am, CO
monoxide,
can be irritating. No?
CO will be not that much irritating. Ozone is irritating. Bache. You will not feel that you are taking CO inside your body. But if there is a ozone, if you see that if you are going to the market and if there is a smoke, you will feel like your eyes are burning. These eyes are burning not due to the carbon monoxide, but due to this irritating gas ozone most of the time,
Okay.
or with the aldehyde. So that's why.
Yes, ma'am.
Okay, so okay, and there are some symptoms that we can get if we are taking this carbon monoxide. Akash, a lot of gases are colorless. For example, carbon monoxide, carbon dioxide, and even ozone is also colorless. But if we are talking about nitrogen dioxide, this is a brownish in color. So a lot of gases we have that is colorless. Okay, so symptoms can be chest pain, headache, vomiting, dizziness, upset stomach, weakness, and lots of things can be happen with this carbon monoxide poisoning symptoms. Okay, because we are talking about atmospheric gases, and the gases or the liquid or the solid that are making this air pollutant. Okay, so the one of these gases is the VOC. Okay, this is volatile organic compound. What do you mean by volatile organic compound? These are firstly the organic compound. Secondly, by name you can see the volatile. It can vaporize very easily. Okay, and how it can be formed? Like there are lots of things like as a byproduct. This can be formed. For example, if we are creating some solvent, if we are creating paints, or if we are burning something, then this VOC can be formed. And these VOCs are very important for this photochemical smoke. If there are VOCs and the nitrogen dioxide and the sunlight, then this photochemical smoke will persist for a longer time. This VOC is very important. So you also should know about this VOC as well. I kept this one slide just to let you know that there is a VOC as well that can act as the air pollutant. Okay, yes, here we can see NO2, NO, and VOC, and if there is a sunlight, then this will create the secondary pollutant, that is O3 and PAN, and this is the part of the photochemical smoke. Okay, the next question. Which phenomena is primarily responsible for the erosion of exposed surface of building materials?
Sulfation. Sulfation, madam.
Sulfation.
Anyone is with hydration, oxidation, and carbonation? Anyone is up for this? Okay, the answer is sulfation only. Why sulfation? Can anybody explain why sulfation? What do you mean by sulfation?
Sulfuric acid.
Acid mist will form and it will erode the material, madam.
Yes, if you have the sulfuric acid, then this sulfuric acid, because it is acidic in nature, and you know the properties of the sulfuric acid, whenever there is some surface of building, or let's say anything, that if it will react with the sulfuric acid, then it will erode something, obviously. Then, and this process is sulfation. Okay, the important question is, you people know about the rainfall, and the two important constituent of this rainfall are sulfuric acid and nitric acid. Okay, then what is the pH of the rainfall?
Less than 5.6, madam.
5.6.
Acid rain less than 5.6.
Yes, exactly. Do you know that our rain is also acidic in nature? Why?
Because of carbon dioxide, madam.
Yes, because of that carbon dioxide, this carbon dioxide react with the water and will form this carbonic acid. Okay, because of that carbonic acid, our rain is already acidic. But when this rain will react with the sulfur dioxide, or let's say nitrogen dioxide, then it will form sulfuric acid and nitric acid, and these compounds will let the pH less than 5.6. And if our rainfall pH is less than 5.6, then we will classify that rainfall as a acid rain. Okay, and sulfation is a part of it as well. Whenever yes, someone want to ask the question? Someone raised hand. Anyway, okay. Because we were talking about the sulfuric acid sulfation, then it is important to know about the corrosion as well. What do you mean by corrosion? Can anybody explain? What do you think? What is corrosion?
Oxidation, madam.
Oxidation, even reduction as well. This is the redox reaction. What happens in the corrosion? What's the bad effect of corrosion? Yes, rusting of iron is the example of corrosion. See, rusting is happening only in iron, but we have the copper, we have different metals where corrosion can be happened. Okay, so this rusting of iron is only one example of corrosion. So what happened in this? Corrosion is nothing but this is when we have water, means we have moisture, we have oxygen in the atmosphere. This will react with the metal, and something will happen. I will talk about it. Something will happen that the metal atoms or the electrons will release, and it will create a electrochemical process. So we will talk about it. Let's see what is this corrosion. So this is the electrochemical or redox reaction. Why redox reaction? Because there is oxidation as well as the reduction. So what will happen at the anode? Like if we have iron, this iron will release electron. Okay, it will release 2 electrons. Then this electron will react with the water present in the atmosphere and oxygen. Then this will form the hydroxide. Okay, and when Fe plus O2 plus H2O will react, this will give you FeOH whole square. Okay, so this is the product that is the rusting product, or let's say corroded product. So it will not be the same product that you had initially. So this is the corrosion. And this happened with the zinc as well. This happened with the copper as well. This happened with the iron as well. Okay, so here we can see very clearly. Here we have iron. This iron, because it is in water, and the situation is just like that, it will release some electron. Then this electron will go there. These electrons will react with the oxygen and with the hydrogen. This will create the OH minus, and when we have OH minus and this Fe2 plus, this will create the FeOH2. And here is one example of this rusting. The formula of rust is Fe2O3 dot XH2O. So this is just like that electrochemical cycle in which one will be the anodic side, one will the cathodic side, and exchange of electrons will lead to the rusting of the iron. Okay, this is not that much important for you. The next question is, what is or are the damaging factor contributes to structure failure in porous material when exposed for a long duration? Deepsha gave me some answer. He's correct. That is frost damage and salt withering. What do you mean by frost damage? Frost damage is like you have water in liquid form, you have water in ice form. Okay, so when suppose you have some surface, and in that surface there is some little crack. Okay, in that crack you have some water. This water will freeze and thaw. Freeze and thaw means will freeze, act like the ice, and then will thaw or will condense into the water. Okay, so you know that water and ice have different density. Which one is more dense, water or ice? Liquid or solid form? Liquid is more dense, right? Ice is less dense. If it is less dense, then it will expand. Means ice will expand, and whenever it is in liquid form, then it will contract. So because of season, because of temperature, this water will expand, contract, expand, contract. Okay, and because of this expansion, contraction, there will be like this crack will be enlarged, and this will lead to the structural failure. So this is the example of frost damage. The second is salt withering. Whenever you have some surface, wind is coming with the dust. Okay, and this is giving you the abrasion. Then this will lead to the salt withering as well. Or salt withering, you can say, like if there is a sulfuric acid in the atmosphere, and because this material have some compound, for example, it may be building of calcium carbonate. Then this calcium carbonate, if react with the sulfuric acid, then this calcium carbonate is a salt, and this will react and will degrade your structure. So this is the example of salt withering. So the answer will be the frost damage and salt withering. Okay, the next question is, an observable alteration in the plant when exposed to air pollution is called. Fast, write in the chat box. What should be the answer? Damage, injuries, stomata. Stomata is a part of plant, so the answer should not be stomata. D should not be the answer. None of the above. Sudesh gave me D. This should not be. Then we have two options: damage or injury. Can anybody tell me the difference between damage and injury?
Damage means destroy. Injury means there is a part of the plant will be
See, I give you one example.
Damage to the non-living things and injury to the living things.
Not that much exactly answer it is. Answer is, I give you one example. If you are playing and something stuck to your skin and your blood comes out. Okay, so this is kind of injury, but the blood is in at that level, or in if the situation has been created in such a level that you have to go to the hospital, and you have to do like you have to pay something for this treatment, then this will be known as the damage, not the injury. So injury is like something is happening, something unfavorable is happening, but damage is when there is an economic loss of this injury. Okay, so whenever there is an alteration in the plant, for example, some leaf are browning. Okay, so these are browning, then we can call it an injury till it is not our plant is not dying with this injury, then this is only injury. But if our plant is dying because of that injury, then this is the damage, because this will give you the economic loss. Okay, so there is a difference between damage and injury, and if there is an alteration in plant, then and there is no economic loss out of it, then it is a injury. The next question: which symptom is considered as an acute effect of arsenic in animals? Arsenic problem is very much
Severe salivation.
yes, severe salivation. So arsenic problem is very much pronounced in I think Bangladesh and West Bengal. Why it is? Why there is a problem of arsenic in West Bengal and in Bangladesh? There is a huge problem of this arsenic there. Mining may be one reason. Another thing.
Groundwater contamination.
What, Devika?
Groundwater.
Yes, groundwater. Like in that area, groundwater have a very high concentration of arsenic there. And why it is? Why in the groundwater there is a high arsenic in that area only? Why not here in like near to Delhi or like near to in the southern India? Why only in West Bengal and Bangladesh?
It's available under the soil, so that's leaching down to the groundwater table, that arsenic.
Yes, you can also say yes. There is a like the rock, the geology of that area is like that. The ores, minerals have a very high concentration of arsenic there. Okay, because of that geological formation, because of that geological processes, this again because of leaching or something, under groundwater have a very high amount of arsenic there, and because of that arsenic, like a lot of disease you can observe due to this arsenic. And the one is lesion on your skin. I will show you. But if we are talking about in animals, yes, severe salivation is the acute effect of the arsenic in animal. So let me show something about this arsenic in. So most of the people in the Bangladesh or the West Bengal may have such kind of problem, a lesion on their skin and hand, or like whole skin can be very pigmented, black pigmented, because of that arsenic, and it has a lot of disease that can give that this arsenic can give you. For example, menosis, carotis, bladder, lung, kidney, and skin cancer, death. Then like there are different forms of this arsenic. Arsenite, like if the oxidation state is 3, then arsenate, then when oxidation state is 5. There can be organic forms that are very less toxic. So this is like when this arsenic is combined with the methyl or the methane, then this is the organic form. So but keep in mind that inorganic form of arsenic is very much toxic, and this can be in the oxidation state of 3 or +5. Okay. Here we can see that in the atmosphere, most of the arsenic can be found when it is binded with this methyl. Okay, and here we can see that because I told you that some of the fossil fuels, some of the minerals, some of the ores have that arsenate there in that area. So whenever there is a mining or arsenate are also used in the pesticide as well. So because of the use of pesticide, because of the geological processes such as volcanism, withering, or erosion, there is arsenic compound that are leached to the groundwater. And this can be present in either 3 oxidation state or the 5 oxidation state. This can react with the methyl and may lead to the methyl binded arsenate in the atmosphere. And so this is about the arsenate. Okay, next question is, which of the following pollutant is mainly responsible for forming the black crust on the surface of the stone material?
It's particulate matter.
Particulate matter. Okay. How? Why? Can anybody guess?
Because these are in the solid form and deposit on the surface of that material.
Yes. Yes, exactly. It is in solid in form, and whenever it react with some kind of acids there, then it will deposit on the surface. So this will give you the black crust over there. Okay, and because we are talking about the particulate matter, so if you people know that we like some organization of India such as CPCB, Central Pollution Control Board, measure this particular matter concentration, but only of two size ranges. The one is PM 2.5 and one is PM 10. Okay, and the size may have different role in your body. For example, if the size is larger, then it will not reach into the nostrils. It will not reach inside your body. It will your nose or the nostril or the hairs will not allow that particle to go inside. Okay, but if this particulate size is very less, then at one time it may dissolve into the blood as well. So whenever we have a very minute or the very fine particulate matter, then this will be more dangerous to you. Okay, so try to avoid the fine particulate matter presence in the atmosphere. Okay, next question is, which of the following pollutant is most sensitive to rubber degradation? Nitrogen dioxide, sulfur dioxide,
Ozone 3.
ozone.
Ozone.
Ozone 3. Why only ozone 3?
Because it is releasing the O radiculate particles of O, which will react with the sulfur in the rubber.
Okay, I have one slide for this. If you see here, every rubber has a double bond. Okay, and this double bond can be easily degraded with the ozone, because this double bond will be break down with the two oxygen. And if this is happening, then there will be the crack in the rubber. So if you are talking about the rubber cracking or rubber degradation, then this is because of the ozone. Okay, then the lithosphere includes crust, uppermost mantle, water over the earth, or water beneath the earth. Write down.
Crust and uppermost mantle.
Crust and uppermost mantle.
Yes, crust and uppermost mantle. Yes, yes, crust and uppermost mantle. So here we can see we have earth. In that earth, at the center of it, we have inner core, then upper core, then mantle. Of this mantle, we have asthenosphere as well. Why this asthenosphere is very popular? Can anybody tell? Asthenosphere. Why like they in the mantle there is the asthenosphere. We people talk about the volcano lava, so this is very much related to the asthenosphere. This is the layer of lava from where the volcano so here we have the magma, and then this magma will release into the atmosphere. This will be known as the lava. So in the asthenosphere we have magma. Yes, you want to ask some question? Okay. Anyway, so of this mantle, we have the asthenosphere part, and then above this mantle, we have the crust. So the crust and above this asthenosphere, we have some part of mantle. And so this above part of the the above part of that asthenosphere and the crust will form this lithosphere. Here you can see that crust and uppermost solid mantle. So your question was right. Yes, Arvind, it's a kind of plastic. Okay, the next question is, which household group in developing countries highlighted as having the highest risk for disease development due to their longer duration exposure to indoor air pollution? Diksha
Women.
gave the
Women.
answer women. Why
Women.
women?
Because they spend much time in cooking in the kitchen.
Yes, so people know that still there are some villages where chulas are working, है ना? And yes, no doubt the chapatis that are prepared over the chulas are more tastier, right? More tasty. But somehow these, because there is an incomplete combustion by these chulas, so because of incomplete combustion, a lot of dust, smoke, and everything the woman inhale in the developing country, and this may lead to the indoor air pollution. So obviously the answer should be woman.
And for the developed countries, who are mostly affected in developed countries? The
This will be
elderly.
Elderly members.
yes, elderly members. Yes, elderly members as well as children. Then which of the following is the short-term effect of dioxin on humans?
Dark spots and
Dark
lesions on the
spots and
skin.
lesion on skin.
Yes, see, dark spot and lesions on the skin. So do you people know what is dioxin? Have you heard about this word, dioxin? This is very carcinogenic in nature. Like cancer is so common if you will have dioxin in your body. So this is very dangerous compound. So let's know something about this dioxin. So this is also known as persistent environmental pollutant because it can stay in the atmosphere for a longer time. Then this dioxin has some characteristics. The first is it is insoluble in water, but it can be soluble in fatty acid. And because of that fatty acid, solubility of this dioxin in fatty acid, so this dioxin can be stored in the human body in the animal fats, animal fat tissue. Okay, so this is the reason why it is present only in the fatty tissue. Then if you see here that the characteristic feature of dioxin is that you must have two benzene ring, okay, and this benzene ring should be connected with one pair of this oxygen. So here we can see that this is the group of the aromatic hydrocarbon compound because benzene is a part of this dioxin, that's why it is aromatic hydrocarbon because hydrogen and carbon is there. Then characteristics chemically by the presence of two benzene rings connected by a one pair of hydrogen atom, and these 8 carbon atoms that are not connected to the oxygen can bind with the hydrogen or other atoms of other elements such as chlorine. Here we can see that, and these carbon can be connected with the chlorine. Okay, so how it is formed? Dioxin is also the byproduct of this incomplete combustion, or if you people heard the name incinerator. So whenever there is an organic compound and we want to do the combustion of that completely, then in a closed chamber at a very high temperature, then this is the incinerator. So then this is the time then dioxin can be released, or the burning household garbage, bleaching of pulp and paper with chlorine. There are so many ways by which this dioxin can be released. So can you tell me people, like we talked about so many compounds that are present in the atmosphere as an air pollutant. So can you quickly name them? Like one is dioxin, another is, we talked about that. We talked about ozone. We talked about another thing, VOCs, volatile organic compound. Yes.
Phosgene.
Yes, we talked about phosgene. We talked about MIC. Yes, particulate matter, sulfur dioxide, carbon dioxide. O3 we talked about. We talked about NO. So can you see that how much compound or how much compounds we have right now in the atmosphere. And you know that one compound, literally we don't have that much technology and the scientific group that can identify which one is reacting with which one. We are still making some invention and understanding the procedure. Even what is the answer of the last question? Yes, 3. Dark spots and lesions on the skin. Okay, so okay, let's forget it. So impact of dioxins can be learning disabilities, immune system suppression, lungs problem, skin problem, and lots of things can be happen because of this dioxin, because this is the one of the carcinogenic and very harmful or toxic toxic compound we have in our atmosphere. Okay, the next is clouds are present in. This is very simple question. Clouds are present in troposphere. Yes. Why only in troposphere?
Ma'am, because all weather phenomena take place in troposphere.
Why only in troposphere?
Dust particles are present in troposphere.
Why only in troposphere? My question is that why all weather phenomena are in the troposphere, not in the stratosphere? If you people know that we have some clouds that can be reached in that stratosphere as well. There are some clouds, very rare cloud, but if you, yes, there are some clouds. So,
Due to density.
not due to density. If have you people heard about that convectional currents? So whenever we have moisture in the atmosphere, and if we have conditions like that, this moisture can go because of the temperature gradient, this moisture can go very high. Though because of that condensation happen in the atmosphere. I told you na, in the troposphere we have like cooler with the height. Okay, so whenever there is a moisture that is going up, it will condense at some height because of that lapse rate. Okay, and if it will condense, then it will form the clouds there only. Why it will go to the stratosphere? But there are some currents by which this moisture can go up to the stratosphere as well, but it is very rare, like there is some kind of clouds only. So the answer is troposphere. Okay, which one of the following gas can deplete the ozone layer in the upper atmosphere? Ammonia, methane, carbon monoxide, sulfur dioxide. Yes, it is ammonia. Why it is ammonia? If you people know about this CFCs that are playing important role in depletion of ozone, here ammonia can also act like a catalyst for this depletion of the ozone layer. You can read about it more. Okay, very basic question. Air is or an element, compound, mixture, none of this.
Ma'am, C.
C. Why not compound? Why not compound? You people, I think you people know the difference between element, compound, and mixture. So what do you mean by compound? How it is different from the mixture?
Also contains chemical compounds and other dust particles and everything. So it is a mixture.
Yes. So what's
Compound
the
is
difference?
due to the chemical reaction created.
Yes, Narendra, can you please speak once again?
Compound are the things which are created by two or more elements by the chemical reaction or chemical bonding, while the mixture may be having elements and compounds which are not chemically reacted to each other.
Okay, yeah, this is also one explanation. The second can be like we must have definite ratio in the compound, na? For example,
Yes.
water is a compound, so H2O, there should be two hydrogen and one oxygen. Okay, so the ratio of these elements should be, or this molecule should be definite. But in the mixture, this is not the case. Mixture can be, and exactly what Narendra said, that there is a no like reaction, like for example, N2 is different, oxygen is different, okay, carbon dioxide is different. There are very independent uh, compounds we have, and even we have their solid, we have liquid, we have gases in that chamber of the atmosphere. So this is mixture. Okay. This you can tell, air pollution causing photochemical oxidant production includes. We already have explained this, but this may be tricky for you. Air pollution causing photochemical oxidant production includes. So what are the product of photochemical reaction?
Ma'am, carbon monoxide and sulfur dioxide.
Ozone, peroxyacetyl nitrate, and aldehyde.
Yes, C is the right answer, because
Yes.
we are talking about the product of the photochemical reaction, है ना? So product will be ozone, then pan, we people discuss about this, aldehyde, and some more chemicals we can have as a product. Okay, I think this is last slide or something. The cooling agent in the refrigerator is
Freon.
freon. And why we are worried about this?
Because it's a chlorofluorocarbon.
Yes. So,
They are
and
damaging the ozone layer.
it will deplete the ozone layer, right? Okay, yes. Why we are worried about this freon? Because this is CFC, chlorofluorocarbon, and because of its nature, it has the potential to deplete the ozone layer. So that's why we are trying to find a substitute of this freon, so that our ozone can we can avoid the ozone depletion, right? Okay. Air quality indicator is lichen, moss, algae, none of these.
Lichen.
Lichen. Why lichen? Yes, the answer is lichen, but why? Lichen will grow only at that place that will be the purest. If there is a pollution, then lichen will not grow. And if you know that lichen is a combination of alga and fungi. So there is a symbiotic association between this fungi and the algae. They both support to each other and live together. Okay, so this is lichen, and this lichen can only grow in that area where there is no pollution. So you will not found this lichen when air is polluted. So you can identify which area is polluted and which is not, based on this lichen. You know about this AQI. Have you heard about this AQI? Every time in newspaper you can
Yes.
read that,
Air quality index.
yes, in Delhi the AQI is more than 400, है ना? So
Yes.
can you tell me what do you mean by AQI?
Air
That
quality
AQI is actually, that AQI is air quality index, not air quality indicator. Okay, so what do you mean by air quality indicator?
Observed concentration by standard of all the 5 parameters, whichever is highest will be the air quality index, madam.
Okay, this is the question, like I was appearing for one interview in the CPCB, and they asked me one question about this AQI, that what's the formula based on that. I knew that there are some gases, for example, ozone, lead, sulfur dioxide, and particulate matter. Based on that, some weightage has been given. Okay, some weightage has been given to that gases. Based on that, we can have some number from 0 to 500. But they asked me question like, what's the formula? On what basis you created that weightage for the particular gas? So right now, I don't know about this answer, but yes, you can explore because I didn't explore after hearing that interview. Anyway, so AQI is very important for us because based on that, we can decide whether to go out, whether to walk out or not. Based on that, we can decide like our elder people should go out or not, our children should go out or not, and we can use mask and air purifier. We have a lot of technology by which we can avoid that high AQI if we have in our area. Okay. CFC is not recommended to be used in refrigerator because they this is a very simple question for you. Because they can anybody
Deplete ozone layer due to their high stability.
Yes, because of the high stability and if you people know the survival rate of this CFC, it is in hundreds. Yes. Which of following is the primary pollutant in the atmospheric air? We talked about primary pollutant and secondary pollutant. So you have to identify which one is primary pollutant.
Sulfur trioxide.
Sulfur.
Primary is the chlorine.
Okay, so what should be the answer? Chlorine or
Cl2. Chlorine molecule.
Chlorine.
Yes, chlorine should be the correct answer because we have primary pollutant is SO2. Okay, and when this SO2 will react with some oxygen or some other chemical, that will give you SO3. So chlorine is the primary pollutant. Which of following is not a pollutant? This is trickier question and sometimes answer can be wrong.
Hydrogen.
Not
Carbon
hydrogen.
dioxide.
Yes, carbon dioxide is not a pollutant because this is the permanent gas we have in the atmosphere. But yes, if the concentration is higher, then we will call it the pollutant. Okay, hydrogen is a pollutant. If you people know that hydrogen or the water vapor is have a great potent for this greenhouse gas. So this is the pollutant, but carbon dioxide is not a pollutant. But the answer is somewhere like it is. There is also always a debate about this. Either this carbon dioxide is pollutant or not. But the answer is whenever whatever the concentration, original concentration we have in the atmosphere, if it is maintained, then this is not the pollutant. But if it is higher, then we will call it as a pollutant. Okay, there is a question. What is true about AQI, air quality index? So we have two options. It informs about the color and odor in the area. It can inform about the ozone level in an area along with particulate matter. So which one is the correct answer?
Both.
Both.
Ozone and particulate matter, madam.
The answer should be only second.
Yes, ozone and particulate matter.
Yes, because it is not giving us the information about odor and color. It can give you the how much concentration we have of that compound in our atmosphere, but it can give us the information about color and odor of that in that air. Which of the following is an example of greenhouse gas?
Both A and B.
Both A and B, yes. Can you tell me the global warming potential of methane and carbon dioxide? Like some
Methane is
weightage.
9.
1:16.
Methane is 21 times of the carbon dioxide.
Yes, it lies from 21 to 25. Means one molecule of methane is that much dangerous. Sorry, one molecule of carbon dioxide.
No,
if we have
25
methane,
molecules of methane is dangerous. That equally dangerous than 25 molecules of carbon dioxide.
Yes, yes. So methane is 25 or 21 to 25 times more powerful molecule for the global warming, or has the global warming potential. And carbon dioxide has what value we
One.
have? 1. And this is the reference. Yes, this is the reference gas. Okay, thank you. If anybody have any query or the suggestion, like how should I improve next time, because every time on Monday from 6 to 8 I will take your class. So if you have any suggestion, like what should I add, how should I improve myself, or if you have still any query about this 1 week syllabus, so you can ask me.
Can we get this video?
Yes, you will get it. I will share the link of this video, and even this video will be uploaded on YouTube as per the NPTEL guidelines. So you can watch it on YouTube, and I will even share this
But the
link on NPTEL.
first week video is not yet there, madam.
I don't know about that, but yes, like under NPTEL guidelines, we have to share our slide, we have to share our video link, as well as we have to upload this video on YouTube. So like this is under the guidelines. This will be
Yes, but it will be uploaded by.
this will be uploaded, like there is no such deadline for that, but we try to upload it on that same day or in the next day. So this video will be uploaded at least by tomorrow.
Okay, thank you.
Yeah, thank you.
Ma'am, yesterday's video will be available or not?
What Pranita?
Yesterday's video.
Actually, I don't know who was the TA for the yesterday, so I don't know when he or she will upload this video, but under the guidelines we have to upload this very soon. So I know